Question number 13 asks us to solve a polynomial equation of higher order, and what I mean by higher order is the degree is not 2, it's not a quadratic equation, the degree of this equation is 3, which means it's a cubic equation, and in general what I want that to clue you into looking for. If an equation is a polynomial equation of degree 3, what it means is if you're looking for the maximum number of real answers there could be to that problem, the answer is 3. There may not be 3, but there will be no more than 3 real solutions. But 3 is a good clue at this point in the course to go by. So if I have you look at this equation, and I ask you to solve this equation, please first of all pay attention to the fact that this is not a quadratic, it's called a cubic equation. So the quadratic formula would not be appropriate here. Wouldn't even think of using the quadratic. But I hope that you do think of this. When you see 4 terms, this is already in standard form, descending power order equals 0. When you see the expression on the left contains 4 terms, I hope you think about factoring by grouping, which is the appropriate procedure here. Out of the first grouping, we factor an x squared, leaving me in parens with 3x minus 2, quantity. Out of the next grouping, we're going to factor a negative 9, in parens, leaving me with 3x minus 2. Now, these 2 terms share a common factor of 3x minus 2. So that's my greatest common factor, which I like to put in the front personally, leaving me in parens with x squared minus 9. I always like to teach my students to factor as much as possible, so I do like for my students to see that this would become x plus 3 times the quantity x minus 3. Remember, if this was not factorable, if this was something like x squared minus 7, then to solve that equation equaling 0, you would have to use the square root property. But in this case, we have 3 factors multiplying together to give me 0. So either the first factor is 0, or, either the first factor is 0, or the second factor is 0, or the third factor is 0. In this first case, 3x is equal to 2, therefore x is 2/3. In the second case, x is negative 3, and in the final case, x is positive 3. So there's our solution set, okay? We have 2/3, and we have a positive, or a negative 3. And notice we had an equation of degree 3, and we have 3 distinct solutions. And we solved this using the method of factoring, and factoring by grouping was a great technique here.